It's pretty fun. No, it's kind of fun. Let's do it. I'm recording now though. Let's look at example number 1. So to refresh our brains from what happened yesterday, what we were talking about yesterday. Well, actually, not just yesterday, but the last couple sections. What is the sum of all the angles in a triangle? 180, right? And then, so basically, this third angle is going to be 180 minus the sum of these two, right? So when we say find the measure of angle C, I know that angle A plus angle B plus angle C has to equal 180. So that's what we talked about. And then I add up so angle A is 45, angle B is 100, and then we're trying to figure out what angle C is. So add up 100 plus 45, and you get 145 plus angle C. The measure of angle C equals 180. If you subtract 145 from 145, that leaves you with the measure of angle C. But whatever you do on one side of the equation, you have to do to the other. 180 minus 145 is 35. Okay? So then that means that this angle in here is 35 degrees. Okay? Same thing, we do the exact same thing over here. 100 plus 135. I'm sorry, I said it wrong. 100 plus 35 is 135. Subtract 135 from 180 and you get 45 degrees. So the only way you could get a triangle is if you take those vertices and you add them up and they equal 180. It's the only way it works. Okay. So now it says explain, and by the way, I kind of glossed over that. We found the angles, but we were supposed to determine if they were similar. Are they similar? Yes. Why are they similar? Not length. Yes. They have congruent angles. Now, the side lengths might be different, but we've proved that they have congruent angles. In other words, this triangle has 100 degrees, this one has 100 degrees. This one has a 45, this one has a 45, this one has a 35, this one has a 35. Now, I'm not sure if you measure those or not. I'm not sure if the length from A to B is the same length as D to E. That's a whole nother thing. If it was, in other words, if all three sides, corresponding sides, were equal, then you would say they're congruent triangles. But we don't know that. They didn't give us any information. We can't make assumptions. They look like they are, but they might not be. If we were to measure them, they probably are or are not. Now, this one, so the reason I say this is because in example 3, or question 3, we have to prove whether these are similar or not. So that means the first thing we want to look at see is I can't talk today. See if the angles are congruent, right? So over here for this one, in order to find this, I'm going to say 180. Grab your handy dandy calculators if you guys were grabbed one on your way in. And let's plug it in. I'm going to say 180 minus, and then in parentheses, oh, this is frustrating. My computer's lagging. Then in parentheses, I'm going to say 78 plus 58. Oh, no, it's 70 plus 58. Not quite awake yet today. I feel like today's a Friday. All right, let's see what we got. 52. So over here, this is 52 degrees. Uh-oh, SpaghettiOs. What do you guys notice? Do you guys see it yet? Go ahead. You were going to say it?
Yeah, they don't have the same angles. So.
Yeah, they don't have the same angles. So, see how this one over here says 49?
Yep.
That's no bueno. So let me do one thing here. Well, let's calculate it and see. I'm pretty sure it's not the same. What's going on with my computer? It's like lagging today. Oh, that's not it. Yeah, it's tired too. I get it, computer. I get it. First class of the day. These snotty nosed kids. All right, so this one is 61 degrees. So no, they are not similar. And at first, when I looked at the images, I thought to myself, "Oh yeah, these are similar." Before I thought about the math, because they look the same, don't they? And really, truthfully, they're only like 1 degree off, right? They're just a little bit off. That's it. They're just slightly off. Well, it's more than 1 degree, but it's it's about 3 degrees off. Yeah. So anyways, let's move on to example 2. I'm going to do example 1 and example 2. Now, this is the type of problem that you normally would see in the real world every day, all day, every day. These types of problems are used a lot, like NASA uses these problems, any type of engineering where you want to compare things. If you ever take a physics class, you'll do a lot of this, okay? So anyways, let's go ahead and jump into it. It says, while playing tennis, Matt is 12 meters from the net, which is 0.9 meters high. He needs to hit the ball so that it clears the net and lands 6 meters beyond the base of the net. What is the height, or at what height should Matt hit the tennis ball? So we don't know what h is, okay? But now, if we sketch this out, the net is 0.9, so this is the height of the net, and it needs to land over here. Isn't that a right triangle? Yeah. And so here's the interesting thing that I want you guys to think about. We have 2 triangles. We have this little triangle, and then contained within that little triangle is a bigger triangle, a perfectly drawn triangle. And they're both 90-degree right triangles. So these are, or should be, similar because this angle here is congruent with this angle here, because they share this angle. They both share angle A. Does that make sense? And one thing that we know about similar triangles is that they're proportional. In other words, whatever this side length is, there's a scalar that I multiply that by. It's proportional. There's a scale factor that I multiply that by to get the bigger triangle. And that's the same scale factor that I use on this side to get the length of this side, okay? So they do know some information. We know that this is 6, and we know that this is 0.9. And if I wanted to figure out what this is, by the way, we do know that Matt is 12 meters away. So the way that you set this up is I'm going to compare. Let me rewrite this over here. On my little triangle, I'm going to zoom out, zoom in so you can see it a little better. We need to make sure that we focus on the corresponding sides. So I know on this triangle, this is 9, and this is, or not 9, this is 6. This is 6, and then over here, this is 0.9. Now over here, this is actually 6 plus 12, and I don't know what this is. And so what we could do is we could set up the proportions. In other words, I'm going to say the big triangle on the top. So one of the things I like to do is when I write this out, this isn't very formal, but it always helps me with these types of problems. I say big over small. And you can do small over big, it doesn't matter. But the big triangle, this helps me make sure that I have the proper side lengths on the top or bottom. So I'm going to put the big triangle first. So I'm going to say 6 plus 12. What does that correspond to on the small triangle? Huh?
I don't know.
What do you mean you don't know? This is this side length from here to here. On the small triangle, what side length corresponds with that? 6. Okay? I know this is written in your textbook, but I'm going to try and explain it in a different way. And I'm going to set that equal to another side on the big triangle. Remember, the big goes on top, right? So then I would say is equal to h over 0.9. Now, I wanted you to see it that way because this is the formal language here, and that can be a little confusing. So what does that mean? Well, A to D is the length from here to here, okay? And then A to B is the length from here to here. So that's where they get this 6 plus 12 over 6. And then that has to be proportional to the other corresponding side lengths. In other words, this D to E has to be proportional or multiplied by the same scale factor as B to C. So they put H over 6.9. Or not 6.9, 0.9. So now I want to solve for H, so I got to start moving stuff away. I'm going to move away the 0.9. What is that doing to the H in the original equation? What is this 0.9 doing to the H mathematically? Dividing. So to move it, what do? Multiply. Whatever I do on one side, I do to the other. So when I multiply this by this, they cancel and I'm left with just H. Now when you multiply 0.9, by the way, what is 18 divided by 6? 3. And when I multiply 0.9 by 3, I get 2.7. So Matt has to make sure that ball is 2.7 meters high in order to clear the net. Did you guys ever think of it that way? How many of you guys have ever played tennis? Raise your hand if you've ever played tennis. Yeah. Have you noticed shorter players kind of jump up in the air when they serve? Yeah. Huh? I'm not short shaming. I'm just. Oh. I'm not. Well, first of all, there's nothing wrong with being short. There's nothing wrong with being short. Oh my God. I'm just going to finish this problem. I can't with you guys today. So. Number 4, it says, suppose you set up a proportion so that each ratio compares parts of one triangle as shown below. So now this is essentially what I said. I'm going to focus on the big and the little. So BC refers to the small one, right? So this is the small triangle over the big triangle. In other words, what they want us to do is write it differently and see if we get the same answer. So BC then would be 0.9, yes. And then AB would be 6. Oh, no, you know what? They did it completely different. Whoa, hold on a second. Let me erase this. What they did is they did the small triangle. They did all the stuff for the small triangle is equal to the stuff for the big triangle, which is another way to do it. So I'm going to say the height of the triangle ABC versus the base of ABC, which was 6. Why is my computer lagging? I really don't understand that. And it's doing goofy stuff. Okay. And then what's the height of the big one? Well, we don't know. That's what we're trying to figure out. And then what's the base of this? 6 plus 9. Or 6 plus 12. So now one thing we could do is called another way, when you have a simple proportion like this, you could do what we call the bat and ball method. When you solve proportions, really what you do is you cross multiply and set them equal to each other. So another approach would be is that you take 0.9 and multiply it by the quantity 6 plus 12. And then you set that equal to 6 times h, which is essentially the same math we did before. Okay. My computer is very laggy. I'll check that in a second. So now what's 6 plus 12? 18. Times 0.9 is equal to 6h. Divide both sides by 6. Normally I wouldn't do it this way, but this is I want you to see it's almost identical to the other problem. So then we end up with 0.9 times what's 18 divided by 6? 3 is equal to h. So you get 2.7. Whoops. So you get the same answer. Does that make sense? Okay. All right, let's do this last problem, number 5. Okay. Same. Oh, there's 5 and 6. We'll do them both. So what I'm going to do is I'm going to compare the little triangle to the big triangle. So I'm going to say, for this one, I'm going to do small triangle over the big triangle. So the small triangle, I'm going to do the base first. So I'm going to say 8 over the height. What's the height of the small triangle? H. All right. Now let's do the base of the big triangle. What's the base of the big triangle? 24. And then what is the height of the big triangle? 2. So now if I want to solve this, I'm going to cross multiply. So what's 8 times 2? 16. And then I'm going to set that equal to 24h. My computer is lagging. It has never lagged ever. Ever. 24h. So now what do I do to solve this? Divide both sides by 24. If I divide 16 by 8 and I divide 24 by 8, what does that give me? And also, if you don't know how to reduce fractions, I could just plug it in my calculator. So if I put my little fraction thing here and I put 16, whoops, not 16 divided by 24 like this, but put it as a fraction, it automatically reduces it for me. Now I know it's 2/3 because 16 divided by 8 is 2 and 24 divided by 8 is 3. I know that. This thing is really acting weird today. I know that. Okay. But I could always double check it on my calculator because sometimes I get in a hurry and I make a mistake. Now, I did that kind of quick. Does that make sense to you guys? Did I go too fast? All right, let's try the next one. It says the cable lowers and meets the tree at a height of 6 feet. So let's say this is the cable. So it meets this is 6 feet here and extends out 16 feet from the base. So this is the cable right here. I think. Let me see. A cable meets the tree at a height of 6 feet and extends out 16 feet from the base. If the triangles are similar, how tall is the tree? So we want to know how tall the tree is. In other words, we've got one tiny triangle that looks like this that has the proportions 6 and 16. And then we have a much larger triangle that this is 56, and we don't know what this is. So we set up the proportions. How do you guys want to set it up? Well, let's do big and small. So I'm going to say the height of the tree, which is x, over 56. That's the big triangle. Now, what corresponds on the little triangle? 6 over 16. Now, here's what's going to happen. You guys are going to go to do your homework. And you're not going to think about this, and you're going to put the wrong number in the wrong spot, and you're going to get the wrong answer. So just take your time, okay, when you do this. So, and you got to check for a common sense answer. If this says my tree is 0.92, and you're like, how could the tree be shorter than the cable height? Then you made a mistake. If it says 3,479 or something like that, then you're going to be like, oh, that's way too high. What would you think it would be? Well, one way, a common sense check would be 16 times 3 would be 48, right? 16 times 4 would be 64. So it's probably like about between 3 and 4 times whatever the number is. So what's 6 times 3? Okay. What is 4 times 6? 24. So it's between 18 and 24. Let's see. So I'm going to say 6 times 56. This is doing some very wonky stuff. 336, you say? And then another thing you could do is it's also called the bat and ball method. So I could divide by 16, and that'll give me my x. Right? Do you guys realize that? Okay, what's 336 divided by 16? Is it really?
Yes. Yeah.
There it is. See how easy that was? X equals 21. Feet, of course. You gotta. Mr. Adams has been lacking on your units, so just say 21 feet. Same thing over here. This was 2/3 of a foot. This is really bizarre that it lags. All right. Any questions? So what I'd like for you guys to do now.